removes unnecessary code. It always hurts my feeling, but it does that. Unused code. So that's not going to work so well. So although I always recommend that you don't debug a program, well, you don't consider a program to be hard to debug until you compile it with at least -02 to look for errors. If something gets weird, recompile it with 00. It's just always worth it. Now, unless something really, really goes wrong, like a compiler bug, it should have the same effect. It should be a little slower, but whatever bugs are there will still be there. But 00 will keep it from doing all that nasty stuff. So, like I said, -00 is a bad thing to have in your make file because it will hide lots of errors from you. But if the program is sneaky or you're having trouble with it, I always just recompile with 00. So, lesson learned. Okay, typing in GDB. So, okay, how many, just out of curiosity, I don't know, how many of you guys know all these key bindings? Previous command, next command, beginning of line, end of line, back of character, kill the rest of the line. Typing? You've seen typing. Old people. Okay, so I would call those the Emacs binding commands, but they're the same ones that all the GNU programs have. So any command line program from GNU, which is basically any of them, or Bash or anything, you have these commands. So previous command, next command, move your cursor forward, back, delete the rest of the line, et cetera, et cetera. So if you're that kind of typist, then GDB knows all that stuff. The history, Control-R, that I use to set that mallet command is particularly interesting because those debugging commands tend to get long as you get really particular. So you can always go back to them. If you don't know those commands, please learn them because they work in the shell. All right, nothing is more annoying than standing behind somebody who's got A pipe to B, -ls, fools, floor, greater than, and they type it wrong, and then you see them typing all over again. It's like, oh, come on, hit Control-P, go back, change. So learn those, enough said. Let's see. Print commands. We've looked at a lot of these. I can print a variable. I can print an expression. I can print a pointer as a pointer. I can print when a pointer points to. I can walk through pointers. I can print things in hexadecimal, occasionally useful. I can call functions. You saw that I called mallet. I can call a function, give it arguments. I can give it arguments and add stuff. I can even call printf statements and all sorts of weird stuff. So pretty much anything you could write in a program you can put in the debugger, which is really helpful for what-if kinds of things. What if I hadn't made that mistake? Then would it work? So a lot of times you'll find out that making these changes on the fly will save you a lot of recompiling and editing. What would have happened if I put that line in? Well, we put the line in and see what happens. So you can do that. We played with list a little bit. List will, by default, start listing at wherever you stop. I can give it a line number. It'll give me a page of stuff starting at line 1. I can give it a file and a line number. It will list starting at that file, et cetera, et cetera. If I keep typing list, it will keep going forward. So if I type, let me say I go back to 1, I say list 1, I want to see the next screen, so I'll just say L for a list, and it'll keep going through because L is unambiguous. Or if you're really, really, really geeky, you know that in GDB, blank lines mean just do the same thing again. So I just hit return. It just keeps doing the same thing over and over. If you're stepping through a program one line at a time, that's extremely useful. Just return, 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 and it'll keep telling what it's doing. So pretty handy stuff to know. Stack frames. We already took a look at this a little bit. It numbers them from 0, the deepest line in your recursion, up to wherever you are. You can go up and down. Now it's always, if I'm here and I want to go here, that's up. It's up in the sense that with this subroutine gets called this subroutine. So this direction is down, even though it's, I always wonder why it doesn't go the other way around. But in any case, I can go up and down very often. If you're only making a small change, up and down are easier to type. If you know where you need to go to frame 2, then I can type frame 2. Info locals is something that I always type in a subroutine. It'll tell you all the local variables. So what's the value of n or some string, it'll give it to you all at once. Often it will also put them in here. But if you forget, you can type that. So those are stack kinds of things. Breakpoints, we played with that a little bit. I can set a breakpoint in the subroutine. I can set a breakpoint at a line. I can set a breakpoint at a line in a particular file, or a particular subroutine. You can list all of the breakpoints, or you can delete a particular breakpoint, et cetera, et cetera, et cetera. Breakpoints are your friend. They're wonderful. Wonderful ways to find out where you are in the program. So we played with those a little bit. Okay, the coolest part of this, conditional breakpoints. So let's say that I've got some program here. Program was that? Here we go. Got a program here called printf. I know most of you are C++ people, so I apologize for that. That has a loop in here. It's going to loop through this thing 100,000 times. And at some point, this line is going to die. Okay, well, I could say, let's run that and break at line 14. Let me just run it and see if it's going to die. Actually, it takes it a few seconds. I used to run faster. It used to die faster. This machine has a lot more memory than last time I talked to Scott. What that's doing is it's appending on the end of a string that has an allocated memory for. So if you're really, really, really patient, after, I don't know, 20 or 30,000 iterations, it'll die. Hey, 47,000 times it survived. Let's say that I want to know, let's say it goes through the loop 100 times and then quits. So I can say break line 14 if I is equivalent to 100. And it'll stop then. So that's a conditional break. Really, really, really useful. The syntax is a little bit weird. So you can do that based on pretty much anything that you want. But if you think about what's involved in doing that, you want to use it sparingly. The reason is that in order to do conditional breakpoints, what the debugger has to do is set a breakpoint between each and every line of your program. Which means run a line, stop, check. Run a line, stop, check. It sounds slow. It's even slower than that. Okay, so if that's the only way to find this, then it's really useful. But I wouldn't want a program that runs for 5 minutes and then does that. That'd be pretty hard. Also beware of the dreaded double equal sign. If x is equivalent to 10, because just like C and C++, if I said break 27 if x equals sign 10, that would be a conditional statement that would always evaluate to true, and it would always break and you never know why. So make sure you're using the right. So very useful. You can make those rules fairly complicated. They do slow down the program quite a bit. But if it's a problem, if it's the case that it only dies, for example, the 14th time some subroutine is called, that can be really useful. We already talked about setting variables. I always use print to set variables in this way because 99% of the time I want to change it because I just printed it, it's wrong, at which time I can hit Control-P, previous command, Control-E-N, equals 10, and I'm done, as opposed to retyping the line. I know it's not that long. But those commands do the same thing, it's just the print one tells you what it did when it was done. So once again, kind of a geeky interface. All right, what about programs that you forgot to debug? Well, or you can't debug directly for some other reason. Let's say it's a program that you didn't start. It's been running and now it's misbehaving, but you can't restart it because then it won't misbehave. So let me give you an example of this. In order to do this, I have to let you in on a secret and first ask you a question. If you answer me wrong, I might not do the example for you, but we'll give you a chance. What is the best computer game ever written? So close, so close.
Doom.
Oh, halfway in between. Hack. Okay, so not a particularly good example by today's standards, but the other situation that you'll see when I run this is there's a good chance I've played this program before at least a couple of times. I'm going to show you an example from this, mostly because it's not graphical and I know the code pretty well, and it's kind of fun to play with. So Let me get a couple of windows here, it'll be a little faster. Who has played Rogue, Hack, or NetHack? Really? Oh, pretty impressive. Okay, actually my kids, my 12-year-old son likes to play NetHack. I don't know what that means. I'd rather not think about it. Okay, I'm going to show you how to play this game. Now the graphics are very advanced. You're going to have to hold on for just a second here. I don't know if I can get this thing into 64-bit mode, but I'll be a spelunker. Must be Oz for that.
Your resolution is too low. I don't know if your machine can support it.
Yeah. Hey, it turns out I'm lucky there's a full moon tonight. All right, so you really don't have to understand the advanced, the really truly profound nature of this program, except that that's me and that's my dog and those are some stairs. So I can walk around. My dog's he's nice to me because I've been feeding him or something. I can walk around and I can get out of the way. Oh wait, a giant rat! Oh no! Okay, well let's see. He hit me. All right, I missed him. He missed me. I'm going to stand here. I wonder what will happen if I just stand here and do nothing. The giant rat hits. Oh, the dog is helping now. If the dog kills the rat, I'm going to be mad. I should have killed the dog first.
Respawn the rat.
All right, okay. The giant rat hits. The little dog hits the giant rat.
Fast magic missile.
Oh, he killed the dog. Oh.
See if you can spawn the rat.
Did you get?
Okay, oh, wait. Okay, a kobold. Those are mean. Okay. He's after me. The dog's nowhere to be found. This is not looking good for our hero. I've really invested a lot in this game. I sure hope I can just stand here and survive. The kobold hits and I die. Oh, no, man. I've been playing this game for 6 hours and I was just killed by a kobold. If only there was some way I could reach into that program and undo that. Well, okay. Here I am in my source code. I never do this. Never, ever, ever do this. And I didn't show you how to do this. Okay. Here's my source code.
You're about to.
All right. Now, the first thing I want to know is the process ID of the thing that died. I know this thing was very small. The process ID of that program is 4509. That might be useful. Okay, so I'm going to drop into my debugger on that program, and I'm going to say attach to process 4509. Now this only works if it's the same user ID. And hey, look, I have a hold of that program. Where am I? Well, let's see. The main program called move monster, which called do chug something, which called hit you, which called hit you, which called lose hit points, which called done in by. That doesn't sound good. Let me go to, let's see, long about some point in here, it checked my hit points. I don't know if you've ever played video games, but hit points sort of as health or something. If that's less than 1, then I was done in by some monster. Okay, and then that subroutine returns. I wonder what would happen if that subroutine hadn't been called. All right, I'm going to use the GDB command return. Oh wait, I'm going to need some more health points first. Print u.u.hp. 0, oh, that's not really enough. Okay, and I'm going to type return. And what that means is make this subroutine return, even though it wasn't in it. Okay, you really want to make it return? Okay, fine, it did, and now I'm going to continue. Oh, hey, cool. Okay. So, yeah, I've got 94 health points, too. That kobold is toast. Okay, so, perhaps, and I'm just saying, perhaps this isn't immediately useful for any of the programs you're doing in your classes or anything. But in general, this attach thing is really useful for working with programs that you either forgot to debug, or it might be a program that was started asynchronously by cron, or it might be started by a different user ID. As long as you're in the same user ID, you can get your stranglehold on that program, and you can debug it. And I always forget to do this. Quit, and now that the debugger has ended, I'm as happy as can be. Okay, so
That just happened.